Hello, and what I'm going to do today is I'm going to introduce the first part of the first unit to the oceanography classes on Planet Ocean. And first thing I have to do is I've got to apologize because this is not going to be a marine biology class. We are not going to study flipper, so no flipper, at least maybe not till the very end of the year. Unit 1, Planet Ocean, a historical perspective. We're going to talk about how the world's ocean can actually move from place to place. A drop of water can actually move from any place and now through the Panama Canal, but it can actually go from any ocean to any ocean. So it is really a planet ocean. Mankind likes to break things up, so we have Atlantic and Pacific and Indian. We have what's called the Southern Ocean, and we have the Arctic Ocean. We even have a North Atlantic and a South Atlantic and a North Pacific, and it actually breaks it up. And we have Tropic of Cancer and Tropic of Capricorns. We have the equator, we have the prime meridian, we have everything. And we are going to learn a historical perspective where we actually did some studies to find this out. And this is probably Cook's trip, but I don't know that one for sure. Many people use the terms ocean and sea interchangeably. Oceans usually are very large. Seas tend to be broken off along a coastline and actually maybe even partially surrounded, like the Bering Sea, with land. And you can see a couple examples of a sea. So the ocean is the large body and seas are smaller and enclosed. Overview, 71%, 87.1% of the Earth is covered by ocean. 97% of it plus is surface water, and it's interconnected globally from the ocean. And if you take a look at the Challenger Deep, goes way down to like there, and if we actually use the Mount Everest as an example, Challenger Deep and the Mariana Trench is actually deeper than Mount Everest is high, and there's Matterhorn, another large mountain. Putting it all in perspective, if we took all the water on the globe, including lake water, and put it in one location, this would be the size of the water. And the way it actually equates to the kids, take a basketball, and if you want to represent the water that's on the outside of the earth, you would put 6 drops of water. So it doesn't even make a wet basketball, it just makes a damp one. Okay, so you can see water in, on, or above liquid fresh water, which is right there, and fresh water in lakes and rivers, which is that little blob right there. So there's all the water, and you break out fresh water, not the ice, but the fresh water that's available in rivers and lakes, and then you take out the fresh water, for rivers and lakes, not groundwater, not ice, and you get that. So it's really not a planet ocean, it's really a planet land with some damp areas. Water cycle, the water that actually makes up the biosphere, the one that makes up 90% mass in your body, as well as all the plants, the flora and the fauna, the plants and the animals, originates in the ocean, goes up through condensation, which evaporated water is invisible. It condenses and actually makes clouds. If the clouds are high enough, they're made out of ice crystals. If it's low enough, they're made out of water droplets, cloud droplets. You get evapotranspiration out of life. You get sublimation, and that's actually ice turning right into vapor without melting. And you have evaporation out of water, either in rivers or lakes or right out of the ground. And then the atmospheric motion can move these clouds. Usually the rain falls right back over the ocean, but sometimes it moves over land where it falls over land. And it actually can fall as ice, it can fall as precipitation, ice and snow, you get the melting, you get volcanic activity putting water up into the air, you get runoff, you get ice moving down, it goes down, it makes streams, it goes into lakes, and maybe groundwater back into the ocean. So this is what's called the water cycle. It basically starts in the ocean, ends up in the ocean. This is called the reservoirs of water. Biospheric water, water that's actually in life. If all the plants and animals stopped drinking water right now, we'd all be dead and dehydrated within a week. Atmospheric water, if water stopped evaporating into the atmosphere and all it did was rain, it would be completely out of the atmosphere in a week and a half. If the rivers stopped collecting water and actually just went downhill and emptied in the ocean, river channels would be empty in 2 weeks. Swamps, 1 to 10 years before they're empty. Rivers and reservoirs, larger bodies, they would actually empty out in 10 years. Soil moisture, because it actually can be locked up, 2 weeks to 1 year. Oceans and seas, if water stopped coming back into the ocean, it would completely evaporate away in 4,000 years. Groundwater, somewhere between 2 weeks if it's shallow to 10,000 years if we're talking about deep water. And ice caps and glaciers and permafrost, if it stopped snowing, they would sublime back into the atmosphere in 1,000 to 10,000 years. So this is the water reservoirs. Some statistics for the planet ocean area. Works out to a really big, these are millions, 361 million square kilometers, 140 million-ish square miles. Mass is 1.4 billion metric tons, or 1.55 billion regular tons. Volume, almost 4 trillion cubic kilometers. Average depth, 3,796 meters. That's if we actually smoothed out all the land and had an average depth. Average temperature of the ocean, 3.9 degrees Celsius, and then it's 39 degrees Fahrenheit. Average salinity, 3.4, almost 3.5 grams per cubic centimeter, or 34,000 grams per cubic kilogram, and that works out to 3.4%. Average land elevation, 840 meters, so you can actually see there's more depth of water than there is elevation on land. Age, about 4 billion years, not quite as old as land, and the future is going to be uncertain. Here's a map of the ocean where we're actually looking at the Atlantic or the Pacific and the Indian. You can see there's the Antarctic Ocean or the Southern Ocean and the Arctic Ocean up there. We do have the Mid-Atlantic Ridge, which is a very large part of the Atlantic. We have lots of volcanic islands and things, as well as the Marianas Trench, which is the deepest place anywhere in the ocean. This is the largest oceanic basin, which makes up most of that area and mass and volume. The world ocean, if we take all the water away again, put an equator on there to divide the northern hemisphere from the southern hemisphere. We need another line right there, which is the prime meridian for the western and eastern, which we'll actually deal with next unit when we talk about maps. If we take a look at these two yellow lines up here between 70 degrees north and 30 degrees north, or 30 degrees north and 70, this is the only place on the planet that's mostly land. This is the land hemisphere, and between these two lines it's 80% land, only 20% water. The entire northern hemisphere is 60% water, so it's more water than land. And then the southern hemisphere is known as the water hemisphere because it's 85% water. When we start breaking the world ocean up into its principal oceans, we're going to come up with 5. The Pacific Ocean, which is the largest, the coldest, and the deepest of any of the bodies of water. The Atlantic, the second largest and the saltiest because it has the Gulf of Mexico and the Mediterranean Sea pumping into it. The Indian Ocean, southern hemisphere, and it's considered the dirtiest ocean because the Himalayan plateau, highest elevation, and 2 very big rivers bringing that sediment down and dumping it into the Indian Ocean. Here's the Pacific Ocean basin. You can see Hawaiian Islands, the Emperor Seamounts moving up into the Aleutian Islands. We have trenches all over here, and we'll actually find out that these deep sea trenches are actually saying that the Pacific Ocean is dying as North America cruises this way. As the Pacific Ocean kind of cruises the way you see these Hawaiian Islands moving that direction. 250 million years ago, North America started moving and South America started moving in a westerly direction. Up until that point, the Pacific Ocean was actually moving away from this rise that you see right here, so it was moving pretty much north-south. Then North America slammed into it, so it still is kind of moving north, but it's also moving towards the west. We have the Marianas Trench and another deep ocean trench. We have one for the Philippines. We have one up here for Japan. We have one for the Aleutian Islands, we have one to Fuca, we have one here for Central America, we have the one along South America, we have Indonesia, all this section, but it's the deepest, coldest, largest basin anywhere on the planet. The Atlantic Ocean, largest thing that you can see in it is this mid-Atlantic ridge from the North Atlantic into the South Atlantic. It does have one trench here for the basically the Caribbean islands, separating the Caribbean Sea again, sort of landlocked. The Gulf of Mexico, where it's actually locked a little bit more. You can also see Greenland, where this mid-ocean ridge is pretty easy to see, is Iceland up here. Then we have the Indian Ocean. Here's the equator, so you can see by far most of it's in the southern hemisphere. It is sort of landlocked. We do have more seas in here where the land is sort of breaking it open. You can see here's part of the Southern Ocean, which we'll talk about here. Arctic is the smallest, the shallowest of all the northern, or all the seas. It's because it's basically sitting on top of continental margin, and it's completely in the northern hemisphere, just like the Antarctic, which is completely in the southern hemisphere. Circumnavigates the lower Pacific, Atlantic, and Indian Ocean. It's called the Southern Ocean, and it basically doesn't have any land masses. It's the only ocean that can, where the water can go unhindered by land masses. So here's the Arctic Ocean, and if you take a look, this lighter color is the relatively shallow areas. So it does have some deep water, but most of it is the shallow area. It's also not very large, but it's completely in the northern hemisphere. And the southern hemisphere, I guess I should have pointed out the prime meridian's location. So this is going down to about, I don't know, does it tell you anywhere? It's not making it to, yeah, it's not making it up to the equator, but basically it's unhindered. It moves around. It is sort of curtailed in between the bottom of South America where Antarctica goes up. It's actually some of the fastest water on the planet as it moves through there, and made it really difficult for the whaling ships for the Atlantic to make it into the Pacific to go out. And once we killed most of the whales in the Atlantic, found out there were a bunch in the Pacific to kill as well, but it was a very treacherous part of the ocean. Comparison to land and water. Average depth again 3,686 meters. Average elevation about 800 meters high. So if you took all the land and separated or spread it out over the planet, it would be about 800 meters. Took all the water, flattened all the land, and did that, the average depth would be a little less than 4,000 meters. Deepest ocean Marianas Trench. Deepest ocean Marianas Trench is way down here. Makes up very little of the Earth's surface, just like Mount Everest way up here makes up very little. Mountains make up very little of the Earth's surface, just like the really, really, really deep water makes up very little of the surface. The average depth of the ocean is right around the abyssal plain, and the average elevation height is, you know, up in sort of like the hill area. This is called the hypsographic curve, where we actually look at the area, square kilometers of the ocean versus the land. You can see water, both coastal land and shallow water makes up a large percentage of the square miles. And this is what's actually talked about cumulative areas of the Earth's surface, where very little of the land is very high and also very low. Hypsographic curve. This is actually a really cool depiction of the ocean. It also has freshwater lakes. As you can see up there, there's Lake Superior. And it actually talks about a radio tower, and talks about continental margins, and it talks about deep abyssal plains and deeper abyssal plains and deeper abyssal plains. It even has a couple of folks down here, David Bowie and Freddie Mercury, sitting down here, and it's the Under Pressure song that they sing. They just put it down there to be cute. If you take a look at some of the things that are up there, you can actually see that you know, sperm whales make it down to there, and you can see lots of other things here, which I'm not going to talk about. Does have a couple of man-made objects where we actually drilled down to find oil all the way down here, deeper than the Mariana Trench. And Russia actually drilled down to actually see if they could reach the mantle, but they found out that the rocks got so hot that their drilling rigs were melting before they got down that deep. The one thing you have to understand here is it talks about the depths of animal ships and boats. Lengths are to scale, the horizontal distance is not. If you look at the Marianas Trench, it actually looks like it's a very steeply sloped trench. This is what it would look like if you looked at it in real horizontal scale. So it still has this sort of shape. You can see that little blob and this little blob, like right there and right there. And you can see this little thing up there, and you can see that little thing right there, and you can see this flat plane right there. So it really doesn't look anything like what we normally think of as a trench, but it is a very deep depression. This is Mauna Kea, the tallest mountain on the planet, where we tend to draw them. Now it doesn't really show on this map, I don't think, but if you drew it to scale both horizontal and vertical, you can see the vertical scale is nothing compared to the horizontal. We like to actually see the things look like this, but they really are much wider. And I think this is the last slide. I'll go to it. Yes, it is. So I'm going to call it quits there. So thank you for stopping by. I appreciate it, and we'll start the next section soon.